Hi there, welcome back. Today we're going to start chapter 6, which is on integration, and we're going to look at some applications as well. So just looking at this first paragraph about this chapter, we've spent most of this semester learning about the derivative of a function and how it's the rate of change of that function. So everything we've been doing has been about finding derivatives and applying that to real-world situations. So we're going to touch base at the very end of this semester in what are called finding an integral, okay, which is integration. And when you do an integral, all right, you're basically going backwards. You're going to be given the rate of change function, which would be the derivative, and you're going to find the original function. We're just going to touch base on this in the first few sections. We can't go into it in full detail because we are running out of time, but we're going to look at least the beginning process of this. So if you guys do need to take more calculus, you'll have a good idea of what integration is all about. All right, so what we're going to do today is we are going to learn how to integrate. Okay, we're going to use the definition of what an antiderivative is, and then we're going to use these rules and find some new functions with that. All right, so first off, it says the process of reversing differentiation. Remember, that's how you found derivative. The process of reversing that is called antidifferentiation. So when you go backwards, you're finding what we call the antiderivative. So it says if capital F and lowercase f are two functions and f prime of x, capital F prime, is equal to the function for all x in the domain, then capital F is the antiderivative of f. Okay, so in this notation, when you're looking for capital F of x, that would be the original function where it is the antiderivative of f. Okay, so it gets a little confusing with the letters, but please understand, as long as you know you're finding the antiderivative, you will be okay with the letters. So just try to remember that capital F is what we use for antiderivative. You should know that because everything we've been doing is little, right? We've been doing F prime, G prime. Those are always small letters. So today you're going to notice we're going to use the capital letters. So that means something different, and that's the antiderivative. All right, so number 3 says, okay, given that capital F, sorry for the barking dog. I don't know what they're barking. All right, so given that the antiderivative of f of x, the indefinite integral of f of x is symbolized by this notation. So when you see this symbol right here, and then f of x, d of x, that means you are looking for the antiderivative. Okay, that's an indefinite integral. Now, when we find an indefinite integral, we're going to do the antiderivative of what's given to us, and then we always have to add and tack on this plus c. It says c is an arbitrary constant and is called the constant of integration. We'll talk about that when we get into our first few examples. Number 5 says in the indefinite integral that we have, okay, f of x is called the integrand and d of x is called the differential. So again, you would use this moving on forward, but just so you understand that this little notation means you're finding the antiderivative. This is the integrand, what you're finding the antiderivative of, and this is the differential, which is just, again, in terms of derivatives, we know what we're looking for, what's the variable. So this would be x, okay? All right, so today we're just going to look at the basic formulas and do a couple of these on the notes. Okay, so 6 and 7 give us our basic rules. So when you're integrating a constant, okay, k is your constant, the integral or the antiderivative will be kx plus c. Okay, when you're finding the antiderivative of x to some power, you're going to take whatever the power is and add 1 to it. So it'd be 1 over r plus 1. So whatever that is, plus 1. And then x to the r plus 1. And always at the end, we're going to tack on that plus c. Now, 1 over x is special because if you remember, the derivative of the natural log of x is 1 over x. Remember, we're going backwards. So if you see 1 over x, that means the original function was the natural log of x. Now you're supposed to put absolute value signs around it, so please note when you're working in Hawks and if you're looking at test questions or review questions, you're going to see that. If you leave it off paper, that's fine, but just get in the habit of making sure that you put that. That is important that we have that absolute value there. So 1 over x, if you're integrating that, that would be the natural log of x, and again, plus c. We know that the derivative of e to the x is e to the x, so the antiderivative of e to the x is e to the x, so that's a nice one, plus c. And then we have a few rules that in case we have more than one term. Okay, so these are like those power rules that we did. So the first off is if you have a constant times a function and you're asked to differentiate that, or I'm sorry, you're asked to integrate that, then you're going to do the rule for the function, whatever the function is, and then just multiply that constant times it. So kind of like we do when we found the derivative. And then if you have more than one function, so terms that are added or subtracted, you're just going to integrate each term individually. And then they did not write this here, but again, all of your antiderivatives will have this plus c at the end. So if you were doing this function and you did plus c, and then let's say g of x was this, and you don't need 2 plus c's, okay? So when you're breaking up a power rule problem, you just make sure at the very end you only need 1 c. So you don't have to do it for each problem, okay? So just a c at the end, and we'll go through that and I'll kind of explain that in just a minute. All right, so those are the only rules we're going to need today. So we're going to use these and do some anti-differentiation now. So one of the things, just to make sure you understand, I want to make sure about that plus c. So, let's say your function was 3x to the 4th plus 5. And I asked you to find the derivative. Okay. Well, the derivative is 12 and then subtract 1. So that would be 12x cubed. And the derivative of that is 0, right? So that's the derivative of that. But if I asked you to find the derivative of this function, okay, what would the derivative be? The derivative would have been 12x cubed. So that's the plus c part that we're looking at. So if I give you this today, I'm going to give you this, and we're going to come up with this, okay? If I give you this, we're going to come up with this, but where does this come from? We don't know what that is unless we're given some more information. So that's why we're not going to know this number when we give the answer today, because now this is the capital F. This is what we're looking for today, okay? So if we're given this and we get to this, then that's why we're going to put plus c, because we don't know that yet. We will at the end of these problems, but when we're doing this general antiderivative rule, we're just going to use plus c because that's that constant. And we don't know what it is because all constants had a derivative of 0. So hopefully that makes sense to you why we're putting that there, because otherwise, there could be a bunch of different answers for that. Okay? All right, so let's look at our problems and let's see how this goes. All right, so we're going to find indefinite integrals. So we notice this sign, that means find the antiderivative. Okay, so when you had a constant function, okay, the antiderivative would be k times x plus c. So this is our derivative. So our antiderivative, when I write f of x, would be negative 8x plus c. Okay, and think about that. If this was the function, what's the derivative of negative 8x? It's negative 8. Okay, so there could have been a number, there might not have been a number, but this derivative would have been 0. So we're giving the function, this is the derivative of that. Okay, we're going backwards, antiderivative. All right, now for part B, this is where we have two things. So when you have two parts, like it says at the very bottom of the page before, we're just going to take the integral of each individual function first and then add that plus c onto it. So this would be negative 3x to the negative 2 dx plus, and then we're going to integrate 3 dx. Okay? And then when we do that, then at the end we will put the plus c. All right, so this is a constant, so it's going to stay in the problem, and we're just going to differentiate this. So they tell you, back to this one more time, so we got a constant times a function. That equals the constant times whatever the antiderivative is, okay? So we're going to bring the negative 3 out front and just integrate x to the negative 2. This is just a constant, so that's different. So this part is just like this, okay? You only have to pull the constant out if it's multiplied by another function. So this one I can leave the way it is. All right. So what is the rule for x raised to some power? Okay. So we're going to do 1 over the exponent plus 1, and then times x to the exponent plus 1. So negative 3 stays there, times 1 over, we're going to add 1 to this. So negative 2 plus 1. Negative 2 plus 1 is negative 1. And then x raised to this, whatever this is, that's what you're raising x to that power. This plus 1. So x to the negative 1. That simplifies negative 3 divided by negative 1. That's positive 3x to the negative 1. Plus, we know that the antiderivative of a constant is just 3x. And then you have the plus c. Okay? All right. This is the antiderivative, so we call that capital F of x. Now think about it. What I love about these problems is you can go backwards. What would have been the derivative of this? Derivative. Negative 1 times 3 is negative 3. Subtract 1, we get x to negative 2. So negative 3x to the negative 2. What's the derivative of this? Derivative of 3x is 3. So this is the function, this is the derivative. Okay, we're going backwards. So it would make sense that when we did the derivative, we multiplied and subtracted. So the formula says add and divide. Okay, we're going to add 1 and divide. So we're going backwards. Okay, so it just takes a little practice, but most of you guys get this pretty quick. It makes sense. Also, you can always check those answers. All right, so C, we've got the integral of negative 5x to the 4/5 dx, and then minus the integral of 6 dx. Okay. All right, so we're going to use that same rule. So we're going to bring that negative 5 out and just integrate x to the 4/5. And then this stays the way it is. All right. So we got the negative 5 times 1 over, and we're going to add 1 to this. 1 over, what is 4/5 plus 1? 4/5 plus 1 is 9/5. Okay, and then x to the 9/5. You don't have to think about that. Whatever you put here is your new exponent. Okay, and then minus, that's a constant, so its antiderivative is 6x. And then we have plus c. All right, now, this is the only part you guys got to be careful of, because when you divide, okay, whenever you multiply by the reciprocal. So 1 divided by 9/5 is the same thing as 1 times 5/9. So you're multiplying this by 5/9. So that's negative 25/9. X to the 9/5 minus 6x plus c. That is your antiderivative. And then you can check it to make sure you did the rule right. So if you were to take the derivative, 9/5 times negative 25/9. The 9s would cancel, and negative 25 over 5 is negative 5. That's what was right here. And if you subtract 1 from that, you get 4/5. So that was the original function. That's the derivative. Negative 6x, derivative of that was negative 6. constant, derivative of a constant is 0. Okay, so we always have to include that constant because there may or may not have been one in the original function. All right, now, the only thing I'm going to tell you to be careful of is your natural logs. Okay, any other variable of x to any power is rule B. Okay, the only time it is not is if it's 1 over x, which means that is x to the negative 1. That's the only thing you can't do by this rule, because x to the negative 1 is 1 over x, and that's a specific function, which was the natural log. Okay, so any other exponent, negative 2, negative 3, negative 4, any positives, fractions, any other exponents, you do this rule, which we've been working on. But now we're going to see this rule, so you got to be careful. Okay? All right. So we're going to break this up. I'm going to go and put the constant out first. So we've got negative 7, and then we're going to integrate x to the 9th. Minus 6 is your constant. That would leave you 1 over x. We've got dx there. Dx here, and then plus 5 is your constant. This is 1 over x to the 7th dx. Okay? Now, here's what I was talking about on this, because this has to stay like that. This one, however, I'm going to use that exponent rule. So I want to rewrite this as x to the negative 7. Every other exponent you want to write that way, except for this one. So we're going to do negative 7. I just want to rewrite this. I'm not doing anything new here. Okay, but I want to write this guy as x to the negative 7. Okay, why? Because that's that second rule, part B, x to some power. As long as the power is any number but negative 1, because that's got to stay. That's a natural log. All right, so negative 7. Okay, we're going to add 1. Okay, add 1 to 9, that's 10. So it'd be x to the 10th. Okay, again, you don't have to think about it. You're just adding 1. Goes in the denominator, goes to the exponent. Minus 6. This is a natural log, and it's the absolute value of x, right? So that's always true. And then here, 1 over, be careful, we're going to add 1. Add 1 to negative 7, that's negative 6. So x will be to the negative 6. And then you got your plus c. All right, so we're going to simplify. So that's negative 7/10 x to the 10th minus 6 natural log of x minus 5/6 x to the negative 6 plus c. You could write this as negative 5 over 6x to the 6. If you wanted to put the x in the bottom, that's fine. All right, so there's your antiderivative. Getting the hang of it, I hope. It's not too bad. So again, if you want to make sure, if you multiply 10 times negative 7/10, that gives you negative 7, and then subtract 1, x to the 9. Negative 7 x to the 9. Derivative of natural log of x is 1 over x, so the derivative of this would be 6 over x. And then this derivative, negative 6 times negative 5/6 is positive 5 x to the negative 7, which would be in the bottom. Okay, so the nice thing about these is you can check your answer to the original problem. This is the derivative, this is the original function. Antiderivatives, okay? All right, hopefully that's becoming a little bit easier for you. All right, so right here, that's a logarithm. That's a natural log, okay? As long as it's t in the bottom or t to the negative 1 up here, that's your special case. The rest of them are going to use the rule in part B where you're just adding 1, okay? All right, if there's any constants out front, so we're going to bring that 5 out, and we're going to take the derivative of t to the 2/5. So this will be dt, okay, minus 2. That's 1 over t dt. And then this is a constant, so that gets to stay. Right? Constants are a little different. All right. So now we're going to take the antiderivative. So add 1 to 2/5. So 2/5 plus 5/5, 5/5 is 1, would be 7/5. So 1 over 7/5, and then t to the 7/5, okay, minus 2. 1 over t is your special, that's the natural log of the absolute value of t. And then that's a constant, so you just tack t onto that, and then don't forget your plus c. All right, then we just got to simplify this. So again, 1 divided by 7/5 is 1 times 5/7. So that's going to make that 25/7 t to the 7/5 minus 2 natural log of t minus square root of 5t plus c. So that is your antiderivative. Okay? You can check that again. That is the antiderivative. All right. Part F. I got a constant, constant, constant. So I can pull all those constants out. So we got -5, and then we're just going to integrate 1 over x. We're going to pull out the 2, integrate just x to the 3/5. And we're going to pull out the 3 and integrate just e to the x. Okay, so we're just doing each one separately, which is nice for now. Okay. All right, so again, this is your natural log. So -5, the antiderivative of 1 over x is the natural log of x. Okay. Plus 2, this is your power. So we're going to add 1 to 3/5, which would give you 8/5. So 1 over 8/5, x to the 8/5, minus 3, and the antiderivative of e to the x is e to the x. And then don't forget your plus c. So all we got to do is simplify that second term. All right, so this would be 2 times 5/8. 2 times 5/8, which would be 10/8, and I can simplify that to 5 over 4. So this will be 5/4 x to the 8/5. The rest stays the same. So there's your antiderivative. Okay. It's always good to check these. These are, good to check. So 8/5 times 5/4. 5s are going to cancel. 8 over 4 is 2. Subtract 1 from that is 3/5. So 2x to the 3/5, and that is what that was. Okay, so always good to check. All right, moving down to part G. Again, bring the constant out, bring the constant out, and I'm also going to write this in its rational function form. So this is x to the 1/5, and this is x to the 1/2. Let's write it that way. I'll do that over here. Right, that's really what we have. It should be easier this way to do the antiderivatives. Okay, so when we split it up this way. Okay, so we're going to bring the -3 out and just leave the x to the 1/5 as our antiderivative. Bring the 4 out, leave the x to the 1/2. That's what we're going to do. So both of these are just going to add 1 to those exponents. All right, so -3, add 1 to 1/5, that's 6/5. So x to the 6/5. Okay. Add 1 to 1/2, 3/2. And then x to the 3/2, let's see. Okay. So again, when you have any power other than -1, you're going to do 1 over, add 1 to that, and then x to that same number. And then we're going to simplify. So -3 times 5/6, -3 times 5/6, that's -15 over 6. So we can reduce that to -5 over 2. X to the 6/5 minus 4 times 2/3 is 8/3. x to the 3 halves plus c. Okay. All right. So again, you can check. 6/5 times negative 5 halves is negative 3. Subtract 1, 1/5. So that's what we got. Okay. So you can check these. All right. Part H. All right. Now, since there is no such thing as a quotient or product rule with antiderivatives, okay, we have to simplify. So we put a few on your notes because you can't, there's no such thing, again, you're going backwards, so you can't undo a quotient rule. You think about that, that's a little difficult to try to figure that one out. So we're just going to divide each numerator. So let's simplify first, okay? So I'm going to put simplify first. Otherwise we can't use our rules today. So let's divide. So x to the 4th divided by x to the 4th leaves just negative 5. Over here, you're going to have 1x left in the bottom, so 7 over x. And here, you're going to have negative 2x, negative 2 over x to the 4th. Okay? So again, I would write this. This one's got to stay because that's your natural log. But this one, I would rewrite like this. Okay? So any other exponent besides negative 1, because that's got to stay in the bottom, you need to write this way so you can use that second rule. All right, so this is just a constant now, so that's going to stay. 7 comes out, and we're going to integrate 1 over x. And then the negative 2 is going to come out, and we're just going to integrate x to the negative 4. Okay? All right, so constant is just negative 5x minus 7. Antiderivative 1 over x is the natural log of x. Make sure you're putting those in absolute value signs. And the last one is our power rule, so 2 times 1 over, add 1 to negative 4, you get negative 3, x to the negative 3 plus c. So all we have to do is simplify that, which is just negative 2/3. You can write this x to the negative 3 in the denominator, make it x over x to the 3rd down here, but you don't have to. So we're just going to clean that third term up. So negative 5x plus 7 natural log of x minus 2/3 x to the negative 3 plus c. Okay, again, if Hawks says don't use negative exponents, you would write this term as negative 2 over 3x cubed, right? It's the same thing. So I don't mind you leaving it this way, but just pay attention to how Hawks wants you to write your answer. All right, part I. Again, this is multiplication. There is no product rule for anti-differentiation. So we want to simplify first. Okay, so we're going to just multiply. X cubed times 5x is 5x to the 4th. X cubed times 6 is 6x cubed. That's what we're going to differentiate because now we have individual terms. All right, so bring the 5 out, that's a constant, and just differentiate x to the 4th. Bring the 6 out front and just differentiate x cubed. Okay. All right, so add 1, so that 5 stays, and then you're going to do 1 over 5x to the 5th. Okay, adding 1, plus, leave the 6 alone. Same thing here, add 1, so we'll multiply by 1 over 4 and then times x to the 4th, and then plus c. All right, so 5 times 1/5 is 1, so that just leaves you x to the 5th. 6 over 4 is 3 halves, x to the 4th plus c. Okay, so hopefully, as much as we've done today, you're kind of getting the hang of this. Usually you guys, like I said, don't have a whole lot of problems with it. You just got to remember the rule that you're adding now and putting it in the denominator instead of multiplying it. So it's just going backwards. Okay, and again, the nice part is you can check. The derivative of x to the fifth is 5x to the fourth. The derivative of 3 halves x to the fourth would be 12 halves, which is 6x to the third. So always nice, just don't forget that plus c. We're going to use it now on the next page, so you'll see why we want that there. Okay? So far we haven't been given any information to find it, but now on these last few problems we are. All right, we're finally at number 2. Okay? All right, so number 2 says find the antiderivative, capital F of x, which we've been doing, that satisfies the given conditions. So now they're not giving you the integration symbol. They're just giving you little f of x, and they want you to find antiderivative, capital F of x. So we're still doing the same thing. This right here is how we're going to figure out what c is. Okay? So we have a point to plug in this problem. So first we got to find capital F of x. All right, so capital F of x, we're going to find the antiderivative. So we're going to do 4 and then integrate x squared. And then we're going to bring the 5 out and integrate e to the x, right? Okay, so leave the 4 times, add 1 to that, which is 3. So we're going to multiply by 1 over 3 x cubed. Okay. 5, antiderivative of e to the x is e to the x plus c. All right, so capital F of x is 4/3 x cubed plus 5 e to the x plus c. Now we would be done. That's the antiderivative, but now they gave me an ordered pair. X is 0, y is 2. So I can plug that into here. Okay? X is 0, y is 2, right? F of x. This is the x value. This is the y value. So here's our y value, -2, and x's are 0. So we can solve now for c. We got everything else plugged in. All right, so we got -2 on the left. 4/3 times 0 is 0. 5 times e to the 0. E to the 0 is 1. Anything to the 0 power is 1 times 5 is 5 plus c. So we're going to subtract 5 to the other side, and we get c is -7. So now we can write our true antiderivative, which would be 4/3 x cubed plus 5 e to the x minus 7. So now we actually can find c. Okay? So when you're given a point, then you've got to find c and plug that back into, this is what we call the general antiderivative. Okay, because we didn't know anything about what c might be. This is specific. Okay, we now found a specific function that we know for sure goes through that point. Okay. All right, let's find number 3, same thing. Okay, same exact problem. Here's our function. Here's our point. So we can find out what c is when we're done. All right, so we are going to find capital F of x. That's a constant, so we're going to take that out. Find the antiderivative of just x squared. Find the antiderivative of e to the x. Find the antiderivative of 1. There we go. Okay. All right. 6. 1 over, add 1, so that would be 3x cubed. Antiderivative of e to the x is e to the x. Antiderivative of the constant term, you just tack on x to it, so you could write that as minus x, that's fine. And then plus c. All right, so what do we have? Let's simplify that. So 6 times 1/3 is 2x cubed plus e to the x minus x plus c. Okay, we would be done, but they gave us a point. So that x is 0, this time y is 6. X is 0, y is 6. Okay. All right, so be careful. 2 times 0 cubed is 0. E to the 0 is 1. So on this side we have 1. So we're going to subtract 1 over, we get 5. Okay? So just be careful. A lot of you guys see 0, 0, 0, and then you end up with the wrong C value. So be careful with that. All right, so our function then would be 2x cubed plus e to the x minus x plus 5. And that is our constant. Okay? All right. I hope you guys are getting the hang of this. All right, last two problems are some applications, but we're still kind of working the same things here, so don't let this throw you. All right, so look at this problem. The population of a town is growing at a rate given by dp dt equals 216 minus 24t to the 1/2. This is people per year. What is a rate? That is a derivative. So this is the derivative. Find the function to describe the population t years from now if the present population is 9,200. So again, the population now is 9,200. Now is time 0, right? Present, time 0. So we need capital P, the original function, P of t. Okay, that's what we are looking for, P of t. Because this is the derivative of P of t. Okay, so two terms. So we're going to integrate 216 and then minus, and then we're going to pull out the 24. That's a constant, and integrate t to the 1/2. Keep forgetting that, dt. Okay. All right, so integrate 216 with respect to t and t to the 1/2. All right, so this is just 216t, right? Just constant, you tack on the variable. And then 24 times 1 over what? We're going to add 1. If you add 1 to 1/2, you get 3/2. So that would be t to the 3/2 plus c. So our function is 216t minus, so we got 24 times 2/3. 24 times 2 over 3. Okay, remember you flip it and multiply. So 24, 3 goes into 24, 8, 8 times 2. So this would be 16t to the 3/2. All right, so there's our function, but they gave us a point. They said now, at time 0, population is 9,200. So 9,200 when t is 0. Oops. Okay, that's a 0 right there. All right, so this time we have 216 times 0, that's 0. We have 16 times 0 to the 3/2. Well, 0 to any power is 0. 0 times 16 is 0. So this time it does work out that that is actually this value of c. So our function for population is 216t minus 16t to the 3/2 plus 9,200. Okay? All right, so got to pay attention to the fact that present, if it's time, that's P of t, time is 0, and that's what the population was. Okay? All right, number 5 is marginal revenue, which remember, marginal revenue is simply the derivative of revenue. So the marginal revenue from selling X cameras is 189.06 dollars per camera. That's a rate, dollars per camera. That's a derivative. Okay, find the revenue function, and again, they're giving you a point on the revenue function. So this is the derivative. This is R prime. We want R, which is integrating, going backwards. So we're going to integrate 189. I guess that would be Rx. And then we're going to integrate 0.0. 6x. Okay. All right, so this is just a constant, so that is 189x. Okay. And then here, this is x to the first, so we're going to add 1, don't forget. So 0.06 times 1 over 2, and then x squared. And then we got our plus c. I should have brought this out front. I forgot that should actually be in front of that. Okay, that's the constant. That should be here. Okay, my mistake on that one. All right, so this is good. So here's our revenue function, 189x, and we just got to simplify this guy. So we've got 0.06 divided by 2, so that's 0.03x squared plus c. And again, look at this. Everything's 0. So this side's 0, the x is 0. So guess what? C is 0, right? Everything's 0. That's 0, that's 0. So C is 0. So that means your revenue function doesn't have a C. You could put plus 0 if you wanted to. That's what we got. Okay? You could put plus 0 here. That would be okay. All right. So you guys now know how to find an antiderivative, which is pretty cool. We've been spending so much time on derivatives. So it is kind of interesting. And a lot of times, again, in real life situations, the rate is what you know. And if you know a rate, how do you go back to the actual function? So that's why you need to be able to integrate, okay, or do the anti-differentiation. All right, so let me know if you need any help on anything. Otherwise, hopefully you can get through the homework, and I'll see you back here next time.